Welcome, everybody. My name is Walt Catlett. I'm the Texas Concrete Pipe Association state engineer, and I do a lot with the training side of the house. One of the initiatives we've implemented this year is providing an opportunity for our associates to spend some time with us, and we're super excited to have Afinitas doing that today. And Jason Banwart is going to take a moment and walk us through some things that I think we would all benefit from. So with that having been said, I'm gonna go ahead and get this thing going. I'm gonna read Jason's bio to everyone. After graduating from Iowa State University with a Bachelor of Science degree in mechanical engineer, Jason began his career in the pipe and precast concrete industry in 2010 in the engineering department of Hawkeye Petershop. Now we of course refer to it as Afinitas. In his nearly 13 years with the company, Jason served in a number of roles, including mechanical engineer, project engineer, pre-sales and applications engineering leader, and in his current role as director of technical sales for Afinitas. Jason's worked with producers throughout the world to help them find the right equipment and automation solutions for their specific pipe and precast concrete production applications. And today we have him here before us, and we're super excited about it. Jason, thanks for being here, and thanks for being part of our webinar series. And I'm gonna hand it over to you and let you rock and roll.
Sounds good, Walt. Thanks for the intro. And I'm gonna share the presentation. Hopefully everybody can now. I guess Walt, tell me if you can't, otherwise I'll assume it's
you can
up.
see it. You're good to go.
All right. So yeah, as Walt mentioned, we're gonna talk about 5 simple ways to amp up your plant automation today. And like Walt said, I'm Jason Banwart. Been in the industry for about 13 years, and absolutely love discussing and collaborating with customers on automation solutions. And so I'm excited to be able to talk about it today. And I'm with Afinitas. For those that maybe aren't familiar, Afinitas is kind of a newer name in the industry, but it's comprised of a bunch of brands that have come together to form Afinitas, with brands like Hawkeye Petershop, BFS, New Hampton Metal Fab, Spillman Company, just to name a few of the bigger ones. So Afinitas is a global leader in the design, manufacture, install, and servicing of equipment used in precast concrete and infrastructure. Founded in 1915, and our headquarters is in St. Louis, Missouri. We have about 400 employees across our global company footprint. And if you look at our installed base of precast products and equipment, we're in about 65 countries and all 6 continents. So we have equipment all over the world. We've got a broad portfolio, and we've kind of organized into 3 divisions. So we have the equipment and automation division, which I'm a part of, which would be Hawkeye Petershop and BFS brands. And then we also have a forming systems division and a concrete accessories division. Forming systems, it would be New Hampton Metal Fab and Spillman Company making wetcast forms. And then the accessories division selling things like spacers, stirrup mats, steps, lift devices, anything that's used in concrete production as an accessory. So that's just a little background on who I am, where I'm coming from. And today, excited to talk about automation in the concrete manufacturing space. So as we walk through this, we're going to hopefully understand why it's more important now than ever to automate. We're going to talk about ideas of different facets of your production, how that could potentially be automated. We're going to think about what's the right questions to ask as you're looking at automation solutions, and then what are the benefits of automation for you and your customers. And what we've got in the queue here is 5 scenarios, just to get some ideas. We're going to talk through them and hopefully get some ideas flowing in your minds as you think about your operation, and hopefully you can come away with some ideas that might be helpful that you could potentially implement. But first, I want to talk about a few numbers here related to automation. So as we think about some common challenges that producers may face, as I travel around and work with producers and ask, what kind of challenges do you see? By far the biggest thing I hear is finding and retaining labor. Doesn't matter where you go within the US, seems to be a pretty pretty big problem at the moment. So Deloitte, according to Deloitte, by 2025, which isn't that far away, there's going to be around 3.5 million jobs available in manufacturing. Up to 2 million of those might go unfilled due to lack of available talent. And so how can automation help with that? Well, we can drive labor out of a process, reduce labor in some cases by up to 50% or more. Another challenge is just being more efficient with what we have. So McKinsey did a study and they found that productivity growth in the construction industry as a whole has really plateaued and has only grown about 1% over the last 2 decades. So certainly don't want to get stagnant, in our productivity and efficiency. And with automation, we can really help to drive greater productivity. And then as far as profitability is concerned, according to Forbes, inefficient processes can cost companies 20 to 30% of revenue every year. And so if you think about your operations, your processes, if you can drive out material waste, rework, variation in quality due to human intervention, just how much labor is going into your process, the amount of time things are taking, the more you can drive those out, the more ROI you're going to have. So let's dig into the automation, and we'll start with example number 1. And we're going to talk about the post-processing side of pipe production. So we consider where the pipe is cast, at the machine and then cured. That's kind of the production side. And then the next day, when you come in to tip out the pipe and remove the joint rings and process the finished pipe, that's what we're referring to by post-processing. So let's consider a scenario where a customer is producing between 12-inch and 48-inch RCP. They've got an automated production process in place and a curing process in place. But the challenge in this scenario is the back end. And so as the pipe are coming off the curing area, there's this manual labor intensive process to remove the pallets and the headers. Those rings have to be kind of manually scraped and cleaned, restacked, manually pushed around the plant and brought back to where they're introduced to the production machine. And then the pipe themselves have to be deburred. So when there's little fins at the tongue and the groove of the pipe, you've got to knock those off. Maybe you're marking the pipe. Maybe you're doing some vacuum testing or spigot measuring or any type of QC control. All that has to happen to the pipe as well. So in a scenario like this, perhaps there's 5 or so manual laborers involved, and the output of the plant is kind of limited by this back end process. So that's another challenge. And then the safety aspect as well. So there's the risk of injury. It's pretty well known in a pipe plant that the handling of joint rings and the products themselves is where the biggest risk of injury occurs. So that's kind of the scenario we're looking at. Some considerations that go into a project like this. And so this particular company approached us with a desire to automate. First, you have to look at, is there available space in the existing building? And then, especially if there's parts of the process that have existing equipment, you've got to be able to integrate flawlessly with that existing equipment. Probably by far a majority of the automation projects we look at aren't necessarily a greenfield plant with a clean slate. And you can just design whatever you want. There's limitations in existing buildings and current equipment. And so as you're looking at a project, you want to partner with a team that can really oversee the entire project, design, install it, train, collaborate with you. Another aspect of that is like if you're going to have a time of uninstalling some old equipment and then installing the new equipment, planning the construction to minimize your downtime and getting the new equipment online. And then, of course, when you're looking at automation, it has to provide an appropriate ROI, or it's not going to make sense or get approval. And sometimes in a scenario like this, there's existing tooling that needs to be reused as well, or at least attempted to be reused. And an example would be like joint rings that aren't really necessarily designed to be automatically removed, but they're more for manual removal. So this is an example of a solution that's capable of solving those back-end post-production challenges. It's an automatic system that removes and cleans and stacks the joint rings. And then it also processes the pipe. So it can deburr the pipe, mark the pipe. We can do vacuum testing, spigot measuring, that can all happen with this automatic system. So I've got a video here to play, and it'll give you a good visual of what that looks like. And I guess, Walt, let me know if there's no sound, but it hopefully should show up.
Will do.
Before, we had a crew of 5 people handling the pipe, touching the pipe, cleaning the pipe, deburring the pipe, moving pallets and headers. Now with this automation from Afinitas, we can do it with just one person, and it's safer environment, it's a cleaner environment, and we're gonna have better pipe. And so we're able to keep up with our production. Before, we're always worried about who we're gonna have, who's gonna show up for the shift, are we gonna have enough people to do what we needed to get done? It's almost mandatory that you need new automations to figure out these processes with our issues with getting labor right now.
Personnel is hard to come by, and quality personnel is harder and harder to come by. So that's where automation is going to build out more in the future. It helps us become more reliable, more efficient, and a more streamlined operation. The Rocco machine, I like the efficiency of the way that they designed the machine, the way that they use the shuttle to create independent stations. It makes it much faster in process, as each station is only 60 seconds or so to complete. So a stick of pipe is processed every 60 seconds, and you're essentially dealing with multiple processes.
The engineering support was fantastic. Not everything we had was directly off the shelf, but they had to make things specific for our needs. And I'm grateful for that.
They were also great in terms of the pre-construction as we were doing our site work and we were nearing the installation date. They were great in helping us coordinate and plan. It wasn't just the Rocco that we were installing. We were making changes to the front end of the dry cast operation. So we really had to synchronize those 2 builds together to make sure that we delivered and came back online with production.
The equipment arrived in time. The personnel to install it arrived, and it actually went through in the timing sequence that was promised. And I'm grateful for that. You don't always get that.
I really enjoyed working with Afinitas. Their team is very strong. They have a lot of talent at every level in their organization. They're very good at not only planning, and they were fast to figure out the issues and resolve them, provide timely solutions, and then work with us on getting those solutions built into place with our current schedule.
Before.
Okay, so to kind of summarize the results of a automation system like this is taking 5 laborers down to 1 laborer, and that's a pretty big advantage in terms of labor savings. And then with the stick of pipe being processed every 60 seconds, the post-production now becomes the fastest part of the process, so it's not throttling back your output. With less handling, it's a much safer environment. And then, of course, with it's a more clean, organized environment to work in. So really a good example of a successful automation implementation, really driving labor out of that manual back-end process. And again, Walt mentioned at the beginning, but if you've got questions, throw them in the chat, and we've got Derek monitoring the chat room. So now we're going to consider an example of the reinforcement cage and how that can be automated. So let's look at a scenario where a pipe plant is making 12-inch to 36-inch pipe, and the reinforcing cages are manually moved from a cage machine to the production machine, and then they're manually placed into the machine. And this is very common. You see this all the time. Some of the challenges with that, some areas have a deep labor shortage and they can't even find enough people to properly staff the plant. In terms of output, when you need higher volumes to keep up with the demand, that's difficult to do when you can't find more labor. And then with the cages specifically, a lot of plants I've been in, they get produced on the machine and they're either rolled across the floor and kind of just bunched up in an area, or maybe they're all kind of clustered around the machine, but it can make it a bit cluttered, and there's a risk of injury associated with the redundant manual process of handling the cages. So what if we could have a process where nobody touches the cage through the entire process? That would be fantastic. So, and that was really, the goal here. A project like this takes some on-site visits, takes a lot of collaboration to get to the right solution, because some of these aren't out-of-the-box solutions. It takes some tailoring. Again, looking at the available space in the building, height limitations, and then integrating seamlessly with an existing cage machine and a pipe production machine. And so with that goal of nobody touching the cage, in this scenario, the cage machine was already equipped with automation to load the longitudinal wires and then remove the cage from the machine automatically. So that part was already fairly automated. And then we looked at like a just-in-time delivery of cages to the machine. That really ended up not being a good option, because if there was just too much risk, if the cage machine went down, you know, then you're pacing your production, or if your production machine went down, then your cage machine's waiting. So there's just too much risk of downtime to have a just-in-time delivery. So the solution is an automatic, fully automatic customized system that delivers cages to the pipe machine with no human intervention. And you can see in the picture, we have basically an inventory area where the cages come off of the cage robot. They're stacked up in an inventory area, kind of a buffer zone. And then that manipulator will deliver the cages to the backside of the production machine. So you've got, you know, maybe a couple hours worth of buffer in case the cage machine goes down, or, you know, if the production machine goes down, the cage machine can keep running. So that was the big advantage of having that buffer zone. And I've got a video here to show the equipment in a little better detail.
So our MBK has an ALZM, which is an automatic longitudinal loader. That has drastically, almost doubled our production speeds off of our MBK, which is necessary to feed our Mastermatic. Running 2 pipe at one time, the cage machine has to be able to keep up along with the cage robots, and they are doing that. Our Mastermatic XT150 has reduced our cycle time. It has improved the quality of our pipe. It's helped us to achieve better production overall. In today's hiring market, especially in the COVID times, this has helped us reduce our labor force. The automation is taking place of people that we're not able to find currently. It's not that we necessarily want to reduce the workforce. We want them to work less, work better, more ergonomic, and definitely safer in today's environment.
Okay, so that provided a little more color around that specific situation. So through successfully collaborating, we ended up with a solution that achieved the goal of nobody touching the cage from the time it comes in the building in a roll of wire until the time it's cast into the pipe. The only exception being with double cages, the spacers are still clipped on, but you know, really reduce the labor there. With less handling of the cages, it's a safer process. It's a cleaner, more organized environment, and just a great example of, you know, when you get companies that put their heads together and can work together, some of the great solutions that can come out of that. So. And I liked what Charlie in the video said there. It's not about necessarily, you know, getting rid of people. It's doing the tasks that you can't find people to do. And that's a challenge we're seeing all across the country. All right, so next we're going to consider automating both the production process and the back end post-processing in a dry cast operation. This specific example happens to be about grade rings, but a similar conversation could be had for other dry cast products. So not only the back end automation, but how can we get more automation on the production side to help with driving out labor and reducing cost. So a scenario, let's say there's a grade ring manufacturer where grade rings are manufactured at different locations, maybe some on manual dry cast machines, maybe some in wet cast molds. From what I understand, grade rings can be a bit of maybe a pain to produce, maybe lower margin, just kind of a commodity product. The time it takes, it can be a manual labor intensive production process with kind of the manual demolding off of a dry cast machine. And then once the grade rings are cast, what do you do to get them ready to ship? A lot of people band them together and that can also be a manual process. It can take several people to accomplish that, especially if you have multi-site facility, making a few at each site. And then the output is really kind of limited by those manual processes. And safety-wise, there's a risk of injury whenever you're handling a concrete product or when you're trying to band the grade rings. So that's some of the challenges that could be you could be seeing. Some of the considerations include, can the production of the product be centralized so there's enough volume to automate? Sometimes that's kind of what's going to dictate whether or not you can get an appropriate ROI. Is if you have enough production volume, then that can drive what level automation you can justify. The shape and the size of the products. In this case, the grade rings, can they be made without a curing pallet under each piece? And then how do they need to be stacked or banded or prepared for shipping? All those are important things in the discussion to how these could be automated. So this example includes a front-end robotic solution that removes the products from the production machine and actually stacks them on top of each other for curing. There's no base pallet under each product. And so that saves some time and it saves some cost because the grade rings can just be stacked up, they cure in a stack, and that stack can be processed with a back-end system, which this example also includes. And that back-end system is an automatic banding system that bands and tips out the stacks of grade rings. So we'll watch a little bit of video footage showing what this front-end robotic off-bearing solution looks like. This is at the production station, and then an automatic manipulator comes in, and instead of...
Thanks to the unloading clamp, a product series can be produced completely without base pallets.
So the unloading clamp grabs the product around the OD versus a lot of times in dry cast, you're picking up the product underneath like a steel pallet or a cast iron pallet that's under the product. That's not needed with the way that these are able to be taken off of the machine.
Separates the new concrete ring from the mold while it is still inside the machine. Displaced stacking at several positions and automated use of a release agent enable the fresh products to be stacked directly on top of each other and cured, thus saving space. In one 8-hour shift, the Ring Blitz Mono can produce over 500 grade rings. With the Ring Blitz Duo version, output can be almost doubled and productivity duly increased. Quality, reliability, efficiency. Production of concrete rings is best with Ring Blitz from BFS.
So instead of the machine operator or additional personnel having to kind of manually demold these grade rings, there's just a robotic solution that takes care of that. Stacks them all up, and then they cure just as they're stacked. And then on the back end, we've got this banding system. I don't have a video to show of that, but basically the stacks of grade rings are loaded at this point, if you can see my mouse. And then those stacks are picked up and brought over to a banding station. It automatically wraps bands around the grade rings, and then it picks up that whole stack of grade rings, tips them down, and puts them on a conveyor to exit the building. So literally nobody has to touch the grade ring after it's been cast. It's all handled robotically. So the advantages of going a direction like this is that you're taking the number of laborers at maybe across multiple plants, maybe it's all in one plant, but you're reducing your laborers down to one person operating this entire process, cranking out 400 grade rings a shift. By automating both sides of the production process, you're really driving out the labor. And if you want to talk about gaining a competitive advantage, when you take out nearly all the labor cost component of a product, you can really gain an advantage in the market. And so without that extra manual handling, it's definitely a safer process. There's no more manual banding of the grade rings. There's no more moving the grade ring products individually. And when they're banded together, they actually transport much better as well, so they don't break. So another great example of, in this case, the front end and the back end process being automated. So the fourth example is dealing with the outfeed tipping process in a wetcast operation. And oftentimes this can be a time-consuming and unsafe process. And up until now, the first three examples have been more related to dry cast. This could be more along the lines of the wetcast, precast side. And for this scenario, let's look at a precast plant. They're making large wetcast box products and large round products. And a lot of these are poured upside down and need to be rotated 180 degrees after they're demolded. So there's challenges in time, output, and safety. So the old process would be involving a time-consuming task of hooking up the products to an overhead beam with straps. It's a long process to get the products rotated, get them out of the building, and it's really a lot of times what can drive the need to automate in a scenario like this is just the safety aspect. So having large, multi-ton products up in the air next to personnel suspended from an overhead crane, that can be an area of concern for safety. So some of the considerations in a project such as this would be the available space in the building and any height limitations that there might be. And then really defining what the minimum and maximum product sizes are, what product shapes need to be accommodated. Sometimes a one-size-fits-all solution works, and other times it doesn't. And you have to more look at the 80-20 rule to come up with a viable solution. So, maybe we can accommodate 70 or 80% of the products, where that extra 20% just makes it too complex to cram into one solution. So for this example, a customized tipping system was developed that could tip boxes from a very small, like 3 foot by 3 foot box up to a large 7 foot by 15 foot product, and round products up to 96-inch inside diameter. And we'll take another peek at some video footage showing what a solution like this could look like. So the product is tipped 90 degrees, and then it's basically shuttled to create space, and then allows the product to be turned. And then the product will be shuttled back up against that tipper bed. And when it finishes tipping, the net result is that it's been tipped 180 degrees. And you'll see that this is surrounded by safety fence. There's no personnel standing next to the process. And what were the results? A much safer outfeed process, substantially reducing any risk to employees. So instead of employees standing right next to these massive products being inverted, it's all within a safety zone. It's got an efficient cycle time, 2.5 to 3 minutes to invert a product. And you don't have all the manual rigging, of hooking up these products. Basically, you connect to the product when it's in the mold, you pull it out and set it in this tipping solution, and the product, the tipper does its thing, and then the product ends up right side up, just how you want it to exit the building. So probably the biggest driver here, like I said, was safety, but also just kind of having an efficient and defined outfeed process to get products out the building. And the last example, this is going to be a little more of a holistic plant approach of automating not just one aspect of production, but kind of the wetcast production process as a whole. So in this scenario, we have a precast plant looking to produce, or they are producing manhole and utility products, anything from a small 2 foot by 2 foot box up to a large 72-inch manhole and everything in between. Looking to build a new plant with the goal of drastically increasing their capacity and their output without increasing labor. So one of the big challenges, again, with the staffing is trying to find additional people to staff a new plant when it's already a challenge just to staff the current plant. And they need ability to make more with the current staff. The output demand, higher volumes are needed. We hear this across across the country from producers. Like, we just need more product. The demand is so high. And, in this scenario, the current process, limited the product size because of the existing building and available space. And then in most precast plants, it's pretty common for the pouring buckets to be traveling through the plant with an overhead crane. The products are demolded. They're carried through the plant on an overhead crane. There's people working underneath those areas. You have forklift traffic weaving in and out of the production area to bring in various parts and pieces that are needed. So it can end up being kind of a cluttered, congested work environment in a lot of cases. So some of the considerations that go into a plant like this is defining the number of products that need to be in the system, the size of the products, how big are the molds. That's really going to define how big a building and what height of crane is required. The type of products being run. Some products have different things that need to happen once they get out of the mold. Some have different setup that needs to happen with the molds. Those all play into how the automation can accommodate that. And then if you're looking to add new molds versus using existing molds, or a combination of both, a lot of times the new molds can be kind of custom tailored for automation, where sometimes old molds can work, but they might be compromising some cycle time with the new automation. So there's a lot of things to look at there in terms of really getting the system defined up front. One of the principles of lean manufacturing is creating a flow, and that's what we're doing with this solution. So it's an automated production management system, and it's bringing the assembly line concept. So when Henry Ford started cranking out the automobiles in an assembly line, it's that same principle come into wetcast production. So this animation shows the concept. You have a production loop that the forms or the molds travel through. The products are removed and put on an outfeed line to take the products out of the building. The molds then move down a process line where there's a series of workstations where the mold is set up, cleaned, oiled, and then it ultimately gets refilled, and the full mold travels back into this storage area. Now the storage area is completely safetied off, and there's an automatic device that's managing the inventory. So it picks up a full product that was just poured, places it in inventory, and then it grabs a cured product that was poured the day prior and brings it up to the production line. And so you're creating that flow and giving yourself the opportunity to really get that assembly line efficiency. And this video will show some good footage of an example of what this automation could look like. Okay, so hopefully that gives you a better idea of what that can look like in action. And you compare that to the typical precast plant in terms of the organization, the work environment, and the ability to track what's going on. And it's definitely a large contrast. And it's kind of a mentality shift of bringing the molds to the people on the fill station versus bringing everything to the molds. But it does create that flow and allows you to really organize and streamline production. And we really see the future of the precast, the precast manufacturing going this direction and automating more so than we have in the past. So plants like this can really drastically reduce labor by as much as 50% over a traditional wet cast plant. You get cycle times where you're cycling at maybe 4.5 minutes, and that really drives higher throughput and ultimately higher profitability. The plant conditions we talked about, it virtually eliminates forklift traffic in the plant. There's no overhead transport of the pouring buckets and the concrete products. So making a plant that's more attractive to work in is also helping to bring in employees and retain the employees, because it has the feel of more of a factory setting than a construction site setting. So that can be a real help to retaining employees. And then really, positions your company as a leader with the ability to increase your output and shorten your lead times with automated processes. And as we think of some of the competitive products to concrete out there, a lot of those products are highly automated. So as an industry, I really feel like we need to be continually have in mind, how can we drive automation forward to remain competitive with products outside of concrete that we often find ourselves as producers competing against. So that really takes us through the 5 examples we wanted to highlight, and we'll recap here some of the takeaways. Automation is more important than ever. We've got to ease our labor issues, increase profitability, and really become competitive in the market. And some of these seem like bigger projects, but I think one thing to be aware of is a small change can make a huge difference. And look at adding automation as you grow. Maybe you can work with a partner, a solutions provider that can present phases of automation, so you don't have to bite off the whole chunk at once. And maybe it's like we talked about, looking at just the front end where you're producing the pipe or the product, or maybe it's just starting with the back end and how do we drive labor out of that. When you're working with a partner, ask the right questions. There's always snags or things that come up with fitting into existing buildings and existing facilities. So being open to collaboration and really talking through everything holistically can expose some of those snags in the early phases. And automation it's more than simply making you more efficient. It's about transforming your labor needs. Think about your HR teams and everything they go through with hiring, firing, and retaining, and trying to bring more people on. Like we talked about, trying to have a plant and working conditions that are better than where we've been in the past, and that can attract and retain employees. Transforming the profitability of our business and ultimately winning more business. So I've been excited to talk about this topic today. That kind of wraps up the presentation portion, but certainly would like to open it up for questions. And I haven't been monitoring the chat, but Derek or Walt, did we have any questions come in so far in the chat?
Jason, I haven't seen any questions in the chat, but this will be a great time for Q&A for everyone in the room, no doubt about it. So,
and while we wait for maybe some questions to come in, I have a few common questions that we get asked a lot. One being, how much does this stuff cost? That's usually the big one. What's it cost? Well, it's difficult to say, specifically when there's such a broad range of things that we talked about. It really depends, but it's definitely helpful to talk about budget up front, when you're looking at automation, because if you have a budget that's $500,000 and I come at you with a $3 million automation system, it's not going to make any sense. We're worlds apart. But if we can get a rough idea up front of, what we're looking to do and what roughly we think the budget could be, then that helps anybody that's providing a solution to really tailor the solution. But yeah, cost is usually, one of the big concerns.
your room is quiet today. What's going on, Jason? Got to liven these individuals up, huh?
I guess so.
There, Paul M's got a question for you.
Can the cage delivery system include QC checks? I guess specifically, what are you asking about in terms of QC, Paul? We're not really automatically measuring anything right now with that cage system. Not to say it couldn't be done, but I guess I'm not maybe totally familiar with what type of QC checks are done on the cage itself.
Oh, Paul, you're welcome to unmute and just clarify your question if you want to.
Yeah, thanks, guys. Yeah, Jason, that's what I kind of had in mind. If any dimensional checks, just record keeping of that, things like that.
Yeah, I think that's a good example of something where even if it's not developed, I think things that could be developed. I mean, when you're automatically taking it off the machine and placing it somewhere. There's nothing saying you couldn't add a station that could come in and do some contact measuring or some laser measuring or some type of measuring to do the check. And that's a good example of a lot of times these solutions do get customized based on what the producer needs to have incorporated. So, or maybe it's just a spot where it automatically shuttles every 10th cage into a safe zone where somebody can come in and take a few measurements, and then it shuttles it back in and it's good to go again.
I have another question about your Prima system. Is that primarily designed for self-consolidating concrete?
Yeah, it can work with SCC or self-consolidating or traditional wetcast. And we can look at doing like a vibration table if it's true wetcast, or more of an oscillation table if it's SCC at the filling station. So we have a question here from Johnny Covalt. Do you guys help with ROI studies for your equipment in a startup, in an upgrade, etc.? We do try to help with that, Johnny, and it kind of depends on the situation. But certainly with like the production side, and we look at ROI calculations, and I think one important piece of looking at how fast does automation pay off. You have definitely labor savings, but then there's some things that are a little bit harder to quantify, and there's some things that we as equipment suppliers don't have visibility into where the producer might. But if you're looking at your production is limited and you're turning away jobs because you can't produce enough, like how much are you limiting your top line and what's that worth to you? And what about safety? What about having like one OSHA recordable a year versus having 0? Like what cost do you put on that? How about the HR side of trying to retain labor? What is it costing you in HR headaches to find and replace workers when you have high turnover? So those pieces of it is a little bit harder for us as equipment supplier to help with, but certainly in terms of what the automation can do with a cycle time and how many laborers it's going to take with the automation versus like a current process, we'd love to dig into that type of stuff. So good questions. Anybody else have questions? Another question we get asked a lot is are you seeing more producers automate? I would say yes. It's getting very common for people to inquire about automation, and especially new plants that we see going in. A lot of those plants are planning for future automation. Maybe the CapEx or the budget isn't there up front to do everything, but maybe it's putting the building in with future automation in mind so that it's scalable versus kind of locking yourself into a specific building or size where there's really not room to expand for future automation. But I would say it's kind of definitely has seemed to be accelerated since kind of the whole COVID thing and the lack of the workforce that we're seeing over the past couple of years. Definitely seeing a ton of interest in automation. And I do think that's really good for the concrete industry, like I said, because you contrast it with some of the other drainage products, and those are highly automated production processes. So trying to remain cost competitive in the concrete manufacturing space, I think it's just important to be looking at where we can automate.
Hey, Jason, I got a question.
Sure.
Fling one at you. So if I'm a producer and I'm kind of pondering one of these items, what do I do? Reach out to you and we go visit a plant where it's going on, or what's the process?
Yeah, I would say definitely, reach out, and usually we have some discussions around like figuring out what the producer really wants to do, and then looking, do we have anything that we've done that's similar? And if we do, yeah, certainly going to see it is a good option, because then that helps you visualize it. Sometimes like that cage automation, that was really just a producer coming to us saying, this is what we want, can you do that? And that took a lot of collaboration with their team and our team, and just a joint effort to develop something really cool, that really hasn't been done that I've seen. Maybe it's been done somewhere, but it's pretty cutting edge in terms of taking all the labor out of that back end process.
Yeah, that's cool.
And then of course, working through the plant layouts and looking at the available space and laying our solution in there. And a lot of times if there's existing equipment, it takes, some engineers to come out and maybe do some measuring and figure out how do we integrate with some of the existing equipment.
You get another one from Johnny.
Which process has proven to be the biggest challenge to automate in precast, in your opinion? I would say that cage portion kind of stretched us. Like that was a part that we hadn't done before, where like the post-processing of the pipe and removing the rings and stacking them, cleaning them. We've us and other companies have done that for a number of years now. But I think it's kind of those kind of paradigm shift type projects where it hasn't been done, and it's kind of breaking the mold and doing something new. And I think we're going to continue to see interest in those type of things.
I got another one, Jason. One of our, of course, DOTs are our big customers, and Federal Highway Administration, they really drive the concept of innovation. They want to see innovation, and they reach out to the DOTs and local agencies. Hey, if you got anything innovative you want to share, please share you're doing. You want to share it with us. We'd like to make the world aware of it. And I would say sometimes we struggle communicating the different types of innovative practices that we do in our industry. I'm not saying we don't do it. I just think sometimes we have a hard time having people listen to us. And when I see some of the things you got going on here, and it really screams innovation. You ever get approached along those lines and ask, hey, could you help us shape a message that we share with our transportation partners?
I'm not aware about being approached to share a specific message like that, but it's definitely something that we've had conversations with producers about. It's like a lot of producers do a lot of plant tours, and they're bringing in the DOTs and they're bringing in their customers to show them, this is how your products are being made. And you put in a wetcast automation or some new automation, the fancy bright building, fancy automatic equipment, it makes for a fantastic, plant tour opportunity. So you can bring in people. It's like there is innovation within the precast concrete space, even though, people don't maybe view it that way. And a lot of that innovation, I think, is happening in how the products are made, because the products themselves, a concrete pipe hasn't really changed over the years, but how it's produced has certainly changed, and how it can be automated has certainly changed. So I think that'd be something we'd love to help out with, if we can help drive the industry forward by promoting, the innovation that's happening in the production facilities.
Oh, I believe there's something worth looking into there. I really do. For them to see how innovation has come into play in our manufacturing process. It's part of it. And it increases our feeling on quality, I'm trying to say, our credibility and all that type of stuff.
Yeah. And that is one area I didn't really hit on a whole lot, but just when you have automation too, you're just more repeatable in terms of quality. And, you're able to probably measure and check quality control when it's integrated like into an outfeed process where it's checking every pipe literally. And there's less human, risk for human error. So certainly quality. And that'd be another one of those things where it's an advantage. Like, how do you put a number to make it an ROI, to justify it to an ROI? But it certainly is an advantage.
Sure. You came back and stopped me. We're at 50 minutes after, so we got some good stuff here. But I certainly we're in a position where we could be wrapping up. But I got another one, and you during your presentation, I don't know if I'm sure others heard it as well, but you kept pointing out engineering controls that were in place to protect the workers with all this equipment. You want to touch on that just a second? How important is that?
I mean, that's critical. Like when you're automating and you're trying to drive a much more safer process, if you didn't have the appropriate safety system in place, then you've kind of gone backward in that area, because ultimately we need to protect our workers and our personnel. And we as a solutions provider, we spend a lot of time as we're developing an automation solution. We do a whole safety review and make sure that which we design to the OSHA requirements. So if you have an automatic piece of equipment flying around on a crane and you have a light fence that somebody can walk through and break, there's got to be enough setback distance so that if they walk through and then it trips the crane to slow down, and it takes several seconds to slow down, they can't be able to walk up to it where they could potentially get hit in that amount of time. So definitely with like light barriers, there's those considerations. We try to put hard fencing around anything that we can, but there is just still places where personnel has to interact with the automation equipment as well. So, but we use a lot of redundancy as well with like sensors and locking out parts when a personnel is in there, just so we don't have any accidents.
I saw quite a few practices that you were communicating that it just screams safe practices and taking care of the worker. And so anyway, I just wanted to.
Yeah, that's certainly, that's a huge priority. And I know a lot of the producers do a really good job at really emphasizing that and having great safety programs.
Hey, Jason, I think, how are you good? How you feel?
Yeah,
Good.
I'm good. I really appreciate everybody spending time on here. Appreciate the questions we had. And, if any more questions, throw them in the chat, or feel free to just reach out to me directly anytime. So love to chat about automation, and we'll see what we can come up with for you.
Great stuff, Jason. Thanks for being part of our webinar series. Always great to have Afinitas in the house and sharing some of their innovative practices and different ideas. So thanks for being our guest speaker.
Yeah, you bet. Thank you, Walt, and thanks to TCPA for having us.